Okay, so today we're going to start section 6. We're going to take all those basic functions or basic graphs that we learned yesterday, and we're going to transform them. We're going to slide them. We're going to reflect them. So this is what we're going to do with our graphs today. So the first type of transformation we're going to talk about is if we were to stretch or shrink the graph. So whenever something is being multiplied to your graph, it's going to either stretch it or shrink it. So when I multiply my graph, either if it's an absolute value, or it might be a radical, or even if it's just 2x or 2x squared, whenever I multiply by something, it's going to change the shape. So if you notice, the original graph is in red, and then the one where it got multiplied by 2 is in blue. Notice this one's getting narrower. So notice that it's going up twice as fast. So when they plugged in 2 to the original, they got a 2 back. But when they plug in a 2 in for this graph, then it goes up twice as fast because then it goes from 2 to 4. So it's going to go up faster. Now, if the number is a fraction, notice this one is getting wider and it's going to go up slower. So when the number in front of either the radical or the absolute value is greater than 1, it's going to get skinnier or narrower. When the number is a fraction like this, notice the graph got wider because the original was red and the new is blue. Now, for these, what I would do is memorize what you're going to do with the parent, and then you can also just multiply by 1/2 to get your new order pairs. The next thing we're going to talk about doing with our graphs is reflecting it. Now, what's going to indicate reflection in our graphs or in our equations is going to be a negative sign. So when there is a negative sign outside either a radical, an absolute value, or in front of, say, an x squared, this negative sign indicates that the graph will be a reflection. And the reflection is going to occur across a specific axis. So when it's outside, this would be a reflection across the x-axis. Notice this graph here. Notice the x-axis is like the line of symmetry, and it's going to be reflected. When it's inside a radical or inside an absolute value, that's going to be a reflection across the y-axis. Yeah. All right, so this is a reflection across the y-axis. So if you think about your graphs of your parabolas, let's say we have y equals x squared. Remember this one, if we did our xy points, when we plug in -1, we get +1. 0, you get 0, 1, you get 1. And then the reflection would be y equals -x squared, and that would look like it got flipped, and it would be going down this way. Again, if you did your xy chart, plug in -1. When I plug in a -1 here and square it, notice it becomes, when I plug in -1, I get -1 because you're plugging it in and there's already a negative sign there. If I plug in 0, I get 0. If I plug in 1, I still get -1 over here. So it's a reflection. So here is the rules. So when it's out in front of the function, a reflect across x. When it's inside, reflect across y. Next thing we're going to talk about is if our graph is symmetrical to a specific axis. So if it's symmetrical around the y-axis or the x-axis, and we're also going to talk about symmetry with the origin. So notice this parabola that's graphed here. Notice the y-axis, it looks like it's a line of symmetry. If I were to take that parabola and fold it up, it would match perfectly. So this graph has symmetry with the y-axis. But the way that we're going to test this is we're going to take out the x and we're going to replace it with -x. And if it results in the original equation after we simplify, then you can tell from the equation that it's symmetrical with that axis. And I'm going to do an example of it in a minute. If we wanted to check for symmetry with the y-axis, we're going to replace y with negative y. And then we can see if it's going to be symmetrical. For the origin, we have to replace both x and y with opposite signs. And then we would simplify the equation, solve for y, and see if it ends up being the original. So let me show you an example of this. So here are the rules or the tests that you would do for symmetry. So when you want to test for y-axis symmetry, we're going to take out x and plug in negative x. So here is, I'm going to use this equation. So if I want to do the y test, I'm going to take out x. I'm going to put in negative x. So let's take out the x, put in negative x, and then I'm going to simplify it. If it goes back to my original equation, then it's got y-axis symmetry. So notice when I square negative x, it turns positive, and it does go back to my original. So I would say yes, the graph of this function does have symmetry with the y-axis. Yes. Let's do the x-axis test. Remember, for the x-axis test, we make y opposite. So again, here's the original. I'm going to make y negative. I now want to solve for y, so I'm going to divide everything by -1. Notice it does not make it return to my original. Here's my original. Oh, here's my original. It doesn't make it go back to the original, so this one is not symmetrical with the x-axis. Then for the origin symmetry, you're going to change both x and y to negative. So again, here's the original. Negative y, negative x squared plus 4. And then negative y, this becomes positive. But then I need to divide everything by -1. And I get negative x squared minus 4. This is not my original, so this one also does not have origin symmetry. So no origin symmetry. Even and odd functions. So a function is even when its graph is symmetrical with respect to the y-axis. A function's called odd when the graph is symmetrical with respect to the origin. And these are all just information from your textbook. And you can see some examples. All right, now we're going to start transforming our graph. So first thing we're going to do is transform it vertically. So when I talk about transforming it vertically, that means I'm moving it up and down. Okay? The position or where the number is located, if it's outside of an absolute value, or if it's outside a radical, or outside of parentheses, that number will tell you that the graph shifts up and down. So here are my two functions. The first one, I'm always going to compare it to the basic graph that we learned yesterday. So on the test, you're going to have to show me the original basic one and then how it shifted. Now, technically, you could do a whole table of values here, plug in different values for x, and get a new y coordinate for both, or we can learn how to shift. So what we're going to mostly do is just use the 3 points that are around the origin. So I'm just going to be shifting the -1, the 0, and the 1. So yesterday, we learned how to graph the function y equals absolute value of x. You need to memorize that the absolute value graph takes on a V shape. I'm going to graph these 3 order pairs. You should memorize them, and it's over here. So I'm going to graph 0, 0, 1, 1, -1, 1. Then from there, this -4 tells me that my graph is going to shift 4 units down. So whenever you have a graph, and let's say it's an f of x, we'll show the absolute value. Whenever you have an absolute value and then there's a number outside of the absolute value, either being added or subtracting, this is the shift vertical. If it's minus a number, it's down. If it's add a number, it's up. Same thing if the graph were a square root. If it's outside of the radical, same thing. Minus the number, it would be down. Plus a number, it would be up. You're going to also see some quadratic ones where you might have a function f of x equals x minus 2 squared plus 5. Anything outside of parentheses or outside of radical or outside of absolute value, that number tells you up and down. Positive up, negative down. So the way that we're going to graph, instead of having to do a whole table, I'm going to take these 3 basic points here, the 0, 0, the 1, 1, the negative 1, 1, and I'm going to shift them 4 units down. I'm going to do them one at a time. So my new point here from the 0, 0, I'm going to just take that and move it down 4 units. 1, 2, 3, 4. Here's my new point. Then I do the same thing for this one. 1, 2, 3, 4 right here, and same thing on this one. Connect the points, make your V. Now, keep in mind whenever you take a PSAT or SAT and if they ask you to match a graph, you can always pick whatever X values you want and come up with some Y's. But I find it a lot easier if you memorize the basic function and then just apply the shifts. Let's try a different shift now. Let's do it horizontally. Now, notice this time it's inside the absolute value bars. So whenever there's a number added or subtract within absolute value bars, so like this one is x minus, so if you did x plus 4, it could be under a radical. This is going to tell you to move it left or right, but what's different here is backwards of what you would think. So when it's up and down, if it's plus, it's up. If it's minus, it's down. But for the shift horizontally, left and right, if it's minus a number, this is going to be a shift to the right. You would think it would go to the negatives to the left, but it's backwards because part of the formula is a subtraction sign. So if it's plus, so if it's plus a number, this is going to be left. If it's minus a number, it's going to be to the right. And this is under a radical or in the absolute value bars. So for example, on this one, again, I'm going to graph the basic pairs. So I'm going to do the 1, 1, the 0, 0, the negative 1, 1. This is for the absolute value. So if I do 0, 0, let me do it in red, 0, 0, 1, 1, negative 1, 1, and graph my original. Now I'm going to take those 3 points and shift them 4 units to the right. So 1, 2, 3, 4, put your point. Take this one, 1, 2, 3, 4, put your point. And then the same thing here. Connect the points. Know that the absolute value takes on a V shape. So this would be a transformation horizontally. And for this particular one, we're moving it to the right. So let's practice some of these. So again, if you memorize the basic ones, we're going to do the generic graphs. You're going to memorize those 3 points by plugging in 1, 0, and negative 1. And then we're just going to apply the shifts. So you should remember the x squared, the square root, the x cubed, the cube root, and then the absolute value graph. So remember the cube graph looks like that. This one is the V. This one is the sideways looking S thing. This one is just up here. And then this one is the U. So let's try and shift some of these general graphs. So again, No parentheses here, so this +1 tells me I'm going to shift it 1 unit up. When I go to graph it, I'm going to compare it to the basic x squared graph. Over here, it's a -1, so I'm going to shift it 1 unit down. And I'm going to do these on the next slide. So here we go. Here's the first one. I'm going to first graph the basic graph. Remember the basic points, and again, if you forget, just plug them in. Fix this. So x and a y. So if I plug in -1 and I square it, I get +1. If I plug in 0 and square it, I get 0. I plug in 1 and I square it, I get 1. So I'm going to graph these 3 points. I need to memorize that the x squared graph takes on the U shape. And now I'm going to take these 3 points and I'm going to shift them all 1 unit up from where they are. So 1 here, 1 here, 1 here, connect them again and create a U shape. Again, you can always take the equation, plug in random values of x and do the y that way. But it's a lot easier to just shift those 3 points. Do the next and shift it down 1 unit. So the same basic graph. So again, 0, 0, 1, 1, -1, 1. Connect the points, make your U. And now I take those 3 points, and this tells me that I'm going to shift those 3 points 1 unit down. So move this one down 1, move this one down, and this one down. And again, memorize that it takes on a U shape. Looks like this. It's a little bit higher than that. Let me fix it better. Let me draw the coordinate plane first. So, all right, let me just erase it here. So the x cubed graph would look here, 1. These are the 3 points, but then you like swirl it a little. That's the x cubed graph. All right. Next, again, we still have the quadratic. So again, let's make the original U shape. So we have 0, 0, 1, 1, -1, 1. Connect the points, create your U. And again, this +3, now it's inside the parentheses. So this is the shift where it's left and right. +3, you would think to the right, but we're going to be 3 to the left. It's backwards of what you would think. So I'm going to take these 3 points, move them 3 units to the left. 1, 2, 3 for that origin, and then 1, 2, 3, 1, 2, 3. And again, connect the points, graph your U. Okay, this one's outside of a parenthesis, so which way am I going to shift my graph? Down 2 units. Good. So again, do the parent or the basic graph. So 0, 0, 1, these 3. Make your U. And now shift all 3 points 2 units down. And create your U. All right, again, it's inside the parentheses, backwards of what you would think. This, you would think it's left, but it's really 2 to the right. Again, do the 3 basic points. Make your U. Now shift them 2 units to the right.
Just don't miss class.
And there would be your shifted graph. All right. Oh, this actually has 2 transformations. Not only the negative tells me that this is going to be a reflection, and the 3 is going to tell me it's going up faster, so it's going to get skinnier or narrower. Now, when you're multiplying, what I would do here is take your 3 points, you do them in blue, and when I plug in 1 into this, -3 times 1 squared, and I get -3. I plug in 0, I get 0 out, -1, I still get -3. Now, when you're going to graph this, you don't have to show me how it moved for each time. You can pick one original starting point, and then you can show me the final. But I'm going to show you the 3 phases. I'm going to first show you the original, which I just graphed here. Next thing I'm going to do is graph the reflection. So I'm going to graph this first. Y equals -x squared. So again, this is telling me it's a reflection. So I'm going to reflect it across the x-axis. So that would be the first transformation I would perform. Then finally, I'm going to do it again, and I'm going to do the final one in red, and then that would be applying the 3 times as fast. So then now what I'm graphing are these 3 order pairs that I just multiplied up here. 0, 0, 1, -3. So let's go ahead and now graph these. So -1, -3. Notice how it gets skinnier. So when you multiply your graph, it's going to get narrower when you're multiplying by a number greater than 1. Because again, we're not thinking of this as a -3 here, because the negative sign is for the reflection. We're multiplying it by 3 to indicate the stretch or the shrink. This time we've got a square root. So let's graph the square root first. Then notice this is a reflection, and this is going to be a shift up. So we're going to shift it up because it's outside of the radical, 1 unit. And I'm also going to reflect it. So let's go ahead and get that graph. Now, you could also plug in values for x if you'd rather get your graph that way. But let's go ahead and graph the original in blue. So the original, remember, if you plug in 1 into the square root, you get 1 out. You plug in 0, you get 0. Now remember, we can't have any negatives here. So I'm going to jump to the next x value that I'm going to plug in is 4. Because when I square root 4, I get 2. So 1, 1, and then 4, 2. So this is the original graph. If I were to reflect it, it would come down here. And then now I'm going to shift all those points 1 unit up. So then now, so the red is just the graph of this. Then the green is going to be the whole original problem. So now shift every point up 1 unit and connect your new points. Okay, next we got a lot going on here. Notice we've got the negative sign indicating a reflection. We're going to multiply this, make it get wider. We've got a -1 here. So this is going to tell me it's going to be a shift to the right. And then we've got a +3 shifting it 3 units to up. So let's try and graph the originals. I'm first, and this is the wrong parent. So this was a typo here. We're going to compare it first to the absolute value of x. So let me graph that one first. Again, remember that's the V shape. Now, if I were to reflect it next, so then the next one I could show you is applying this, and then that would just be the point going down this way. We would reflect it or flip it. And then now what we could do is apply the 2/3. So what I could do is take each one of these points and multiply them by 2/3. So 2/3, oops. So if I plug in -1, 0, and 1, 2/3 times 0 stays there, 2/3, and if I put in -1 here and then absolute value it, I still just get positive 2/3 out. Same thing here. So now I'm going to shift these up. So now I'm going to do the graph of -2/3. So now I'm just going to shift them up to 2/3. Put them here, I guess. So notice it's getting wider. Now I'm going to take those 3 points and I'm going to shift them for the -1 now. So I'm going to apply this. So this will be 1 unit to the right. And I'm also going to do at the same time 3 units up. So I'm going to take this point right here. I'm going to move him 1 unit to the right and then 3 units up. So 1, 2, 3, so about here. Same thing on this one. And then your graph would be up here. So you don't need to show every transformation that happens. Choose either the green, the blue, or the red original, and then the new one. So whether you want to just do the basic one, the blue one, and then show me the black one. If you want to do it step by step, you can also do that. And again, this is going to take practice. This is why we're going to practice it again a little bit tomorrow. All right, let's do, and again, don't look at this, typo again. We're going to compare this to the x cubed graph. So we're going to first graph y equals x to the 3rd. So again, when I plug in -1, I get -1, 0, 0, 1, 1. So let's try it. So 0, 0, 1, 1, -1, -1. So this is the original x cubed graph. Notice we're going to shift it 3 units to the right and 1 unit up. So take this origin point, we could go 1, 2, 3 to the right, and then 1 up. Then I can take this one right here at 1, 1, 1, 2, 3, and 1 up. Take this guy, 1, 2, 3, and 1 up. So your graph looks like that. That would be the shifted x cubed graph. Again, don't look at this one. We're going to compare this one to the absolute value of x. So here I'm going to put it at 0, 0, 1, 1, -1, 1. Looks like a V. And again, we're going to shift. So this +3 tells me 3 left. +2 tells me 2 up. So take those 3 points. Move them 3 left, 1, 2, 3, and 2 up. 1, 2, 3, and 2 up. 1, 2, 3, and 2 up. And there would be your new absolute value graph. Next slide has your homework. Again, this homework is due Monday. So tomorrow, for those of you who are here, we will just do more practice of these to get you ready for next week's test. So again, the test is next Thursday. I'm also going to give you back your quizzes tomorrow and your test. And we're going to go over them in class. So in addition to doing the practice, you're going to get your test and quizzes back tomorrow.